prove a result tonight that is very, very similar to Wilson's theorem, but it does require proof. Now, we're trying to show that p minus 2 factorial is congruent to 1, which is similar in appearance to Wilson's theorem. We're assuming that p is a prime, of course. Now, we have a claim right here that's equivalent to saying that p minus 1 is its own multiplicative inverse. P minus 1 times p minus 1 is congruent to 1. That's a claim. And it's proven pretty quickly by this statement right here. P minus 1 times p minus 1 certainly multiplies out to give you p squared minus 2p plus 1. Now, since p squared and 2p are both 0 mod p, you could quickly see that this has to be true. If that doesn't make any sense, you can think of it like this. You could just write down p squared minus 2p is congruent to 0. All right, and that's clear because it's certainly a multiple of p. Congruent to 0. Okay. Now, so this next statement right here is just Wilson's theorem. This guy right here is also known as Wilson's theorem. I'm not going to try to prove that, but it's about pairing up multiplicative inverses, basically. It's not a very difficult proof, actually. Now, so what I'm going to do is I multiply both sides of this congruence by p minus 1, which is going to be very, very useful based on this. So I just wrote that. I just physically wrote that down. I multiplied both sides of this by p minus 1, as you can see right here. Now, what does that do for us? Okay. What happens here is this is going to become, start over here, p minus 1 times p minus 1 again Okay, now what we can do right here, and it becomes fairly clear right here, that's going to knock this down to p minus 2 factorial. Okay, so you'll get p minus 2 okay, and then right here you'll have congruent to, and I'll put parenthetically here, just 1 minus p, right? And of course it's mod p still. I'll leave that out. Okay, but notice that right up here, we just showed fairly straightforward proof that p minus 1 times p minus 1 is just 1. So you see we can just replace this entire object right here with 1. Okay, so we'll come down and do that on the very next line here. So again, this part, oops, and this should be p minus 2 factorial right here. Like that. And again, p minus 1 times p minus 1 is the same as 1. And so we do get p minus 2 p minus 2 factorial is congruent to 1. Okay, and that's because 1 minus p is congruent to 1 mod p, right? If you subtract 1, you get minus p, but that is a multiple of p, right? So we get p minus 2 factorial is congruent to 1 mod p. Okay, now let's go ahead and work just a concrete example of this. Let's say that P was 7, okay? Let's say P is equal to 7. P is a prime number. So P is equal to 7. Now if you substitute that right here, this will become 5 factorial. Is congruent to 1 mod 7. Okay, mod 7. And folks, that's very easy to see because 5 factorial is 120, but 120 minus 1 is 119. And I'll just write down the result right here because I'm running out of room. You get that 119 is a multiple of 7. It's equal to 7 times 17, right? 7 times 17 is 70 plus 49, which is 119, right? So that's 7 times 17. You know, that does it. This is just a concrete example, but this is the main result right here that we were interested in proving. And working it backwards, it's really, you can see it's pretty easy. The big thing that makes it work is that P minus 1 is its own multiplicative inverse. Hope you enjoyed.